So turn to page 292. At the top of the page, an equation can be in standard form, can be expanded and written in general form. But the general form doesn't help us graph it. The standard form helps us graph it, right? When the equation of a quadratic function is in general form, most of the graph cannot be identified, which makes it not very helpful. It is useful to convert to standard form. This can be done by completing the square. So at the bottom of the page, you have some room, and we have already completed the square for quadratic equations, and now we're doing it for quadratic functions. It is very similar, but slightly different. Our goal, if we write out what's the goal, we want to change y equals ax squared plus bx plus c to y equals a x minus p squared plus q. So I'm going to put a box. That's our main goal. And what we're going to do here in green, I'll write the steps. And then I'll leave some space beside the steps, because on the right-hand side, we'll do an example. We factor out the a value. From the first two terms. So in black over here, I'll have an example going at the same time. The example we're going to start off with is y equals 2x squared plus 8x plus 1. So step number 1, you factor the 2 only out of the first two terms. So I took the 2 out of the 2x squared, and I factored the 2 out of the 8x. I left the plus 1 by itself. Step 2, we're going to leave a space inside the brackets and outside of the brackets. That's step number 2. You might not want to write the numbers in. You can just have them in the video, because they might confuse you later thinking, why is there a number 2 up here? So maybe you just draw the spaces. But that's step number 2. Okay? And once you have those spaces, you're going to complete the square. So the question is, what number is going to go in there? It's going to be a plus 4. And if I put a plus 4 in that first space, what have I actually done to the side? I've added 8. Can you see that that 2 hits that 4? You've added 8. So in the second space, we have to undo that adding 8. So we need to subtract 8. Once we've done that, number 3, you can now write it in the standard form. So we have y equals 2. This is x plus 2 squared. minus 7. And we can tell that our vertex is at negative 2, negative 7. We know that it's going up, goes over 1, up 2, over 1, up 6. So if we turn to example 1, wait for it. Example 1 says determine the coordinates of the vertex of the parabola with the equation, and we're going to add and graph. So we'll graph it as well just to practice. Okay? Currently this isn't easy to graph because of the form that it's in. But if we can change it to standard form, it'll be helpful. So what do we do first? We know that the a value is going to be 3, so we can factor that 3 out to begin with. Leave space, keep the 7 by itself, and draw those spaces. What's going to be in the first green space to make that a perfect square? Plus 4. And if we add 4 there, what have we actually added to the side? We've added 12. So to compensate in the other space, to undo that, we would have to subtract 12. It's plus 4 because the only way that you can get that minus 4 would be to have a minus 2 inside that squared. And if there's a minus 2 inside that squared, when it gets squared, there would be a plus 4 in that green space. And 7 minus 12 is negative 5. So what's the vertex? 2 and negative 5. And if we were going to quickly just draw a sketch of this, we have the vertex at 2 and negative 5. It's going to go over 1, up 3, over 1, up 3, over 1, up 3. So you're going to have the point 1 comma negative 2 and 3 comma negative 2. And your parabola will look like this. If you wanted to, you could go over 1 again and up 6. And be, oh, you wouldn't go up 6, you'd go up 9, sorry. 4 comma 7, and you would have 0 comma 7 on this side. We're going to do actually all 3 examples first, and then I'll give you time to work on stuff, okay? So the questions for this one are 3, 4, 5, and 6.